Wonderful. Hello, everyone, and welcome to Managing Technical Debt in a Systematic Way. Our mission at Software Improvement Group is getting software right for a healthier digital world. We do this by providing data-driven and independent guidance to ensure future-proof and trustworthy software for our clients. Today, we are asking the question, how do organizations remain agile and guarantee future fit without being slowed down by their technical debt? We are delighted today to be welcomed, to welcome Forrester Research. We have with us Charles Betts, who's the VP and Research Director, leading Forrester's coverage of enterprise architecture, networking, and sustainable or green IT. He's deeply engaged in researching the transformation of the IT operating model, in particular the impact of agile, DevOps, and product thinking. And from Software Improvement Group, we also have Jasper Gertz, who's the VP and Principal Consultant for the North American region. He leads the consultancy division in North America, working directly with large multinational organizations like Philips, Siemens, ING Bank, companies that have large and complex IT portfolios. And using SIG's measurement-based approach, he helps CIOs, enterprise architects, and software leadership drive innovation and rapidly improve operational efficiency. Now, without further ado, I'd like to hand it over to yourself, Charlie, and to kick things off.
Great. And just checking that you are looking at the right slide.
Yes, we can see it. Perfect.
Okay. And did it advance?
It did indeed.
Marvelous. So thanks again. Thanks, Nick. Thanks, Jasper, for this opportunity to come and discuss technical debt with the Software Improvement Group. I know that we both share concerns and quite a bit of interest in this very important topic. To kick things off is this image here of a very fast-moving boat and a boat anchor, which is often how technical debt shows up and or feels to the organizations that are suffering from it. Now, technical debt, to be specific, is a 30-year-old term, was coined by Ward Cunningham in an OOPSLA experience report. And he said, shipping first-time code is like going into debt. It speeds things as long as you pay it back. The danger is when it's not repaid. And when you spend time on not quite right code, that's interest on the debt. And you can be brought to a standstill under the debt load of unmaintained digital systems. Now, we might see even headlines that arguably relate to tech debt, although when it reaches the headlines, it tends to take a somewhat different form and be focused more at the product patching level for reasons that I'll go into as we proceed through the discussion here. It's not simple to define, especially because we do see so many variations on what we might even mean by technical debt, and that's what I'm going to talk about here today. So in the interest of trying to come up with an abstract definition, I'll offer this, that it's a claim on investment, your investment priorities, which represents, of course, time and the time you're going to choose to spend on solving problems. These are claims on your priorities that are driven by previous decisions, by just the simple passage of time, or even external forces. But there is some loss of agency for you. And so you perceive technical debt as competing with new things you'd like to do, the same way I would love to take my mortgage payment and apply it to more vacation time. However, and I'll just note that you may find yourself having discussions with financial professionals in particular. We have not yet operationalized or defined the term technical debt in terms of accounting standards. And so if you are meeting with financial professionals and they're in the room and you're trying to make this case, you might also want to weave in the terms deferred investment or deferred maintenance, as those are, I think, the relevant accounting constructs. And actually, there's quite a bit of history and establishment of those terms in the accounting profession. We understand that if we don't maintain capital infrastructure, that its useful life degrades, and that becomes something that has economic consequences, for example. So the reality today, though, is that technical debt is a very, very frequent conversation and topic of inquiry and discussion for us here at Forrester Research, and I think for my colleagues at the Software Improvement Group as well. The definitions have clearly expanded beyond Ward Cunningham's initial statement. You can disagree with that. You can say it shouldn't be. We should try to keep to the pure original definition. I have to go with where my customer is, and all of these things have been raised to me as potential aspects of technical debt. And so we will look very comprehensively at the problem here. Well, certainly leading off with the original definition. And what are some indicators of technical debt in software? In the classic, the actual action of writing, usually in a primary programming language, and trying to develop an asset that is fit for purpose and yet will also be maintainable over the long haul. Concepts like coupling and cohesion, those two words used together actually, I think, go back 60 years in software engineering. And yet they still are highly critical and useful explanatory concepts. Software that repeats itself a lot and has opportunities for refactoring. There are many other aspects here. If those of you who are software engineers or lead software engineers, you will be thinking about code smells and anti-patterns. And there are various ways that you can analyze these, sometimes mechanically, sometimes it takes a subject matter expert. Is the software built to be immutable, or do you actually have to recompile it per environment? That's an old practice that is not quite behind us yet. What's your level of test coverage? And I don't want to discount the importance of people's subjective opinions. Now, of course, being subjective, you always have to take them with the proverbial grain of salt. And yet, you can have code that passes all of its tests and has, great code analysis reviews, and yet people struggle with. It's not maintainable. And when you dig in, you realize that there are subtleties in the mental model that the original programmers used that aren't being grasped, or that are inherently difficult to grasp. And those kinds of statements, it's hard to make them, see anybody making them unless that they're a domain expert in the programming language and even in the problem domain. And so subjective analysis remains important. Dynamic analysis, of course, is what we get from real-time monitoring, and so on and so forth. We could do a whole webinar just on this topic, absolutely. But then we would leave behind, I think, other broader aspects of technical debt. You might say, well, this is product level technical debt. The problem is that the product market fit is no longer good. The product is lacking in vision and strategy. It was a great product as far as it went, but it was based on older middleware and integration protocols. So it's not compatible anymore. It is degraded in its stability, perhaps because of underlying infrastructure changes. The user experience, the concept of the application is great, but the user experience is outdated, and you're still using GUI libraries from 2015 or 2010, and so on. Is the product itself been incorporated into a broader portfolio of products that have similarity and overlap? Is the product accessible self-service, or is it accessible for those who are differently abled? Have you dropped it and then ran away into a large organization, left the large organization to struggle with the change management, maybe fail at it? And are there unused features in the product that are becoming more of a risk than an asset? They're more of a liability now due to potential for instability, due even the potential for security abuse. All of these represent product level debt that I think starts to get quite a bit of ways beyond Cunningham's original characterizations. And then we have the product debt of externally sourced products. So the previous slide was my product looking outward. This is somebody else's product looking at it externally. And there's much fewer things to talk about here, but the few things we're talking about here are big ones. You are on an soon to be obsolete version of mega software vendor version database. And in order to move to the new version, you will be paying them very handsome new licensing fees and regression testing 50 or 60 production applications to the tune of maybe 5 million euro. And so you have hard questions that you are faced with. And this is absolutely probably the second and maybe even the most common form of technical debt that people bring up to me. Second most probably. People do bring up the older style, not the older, but the original style of technical debt. But this secondary aspect of technical debt, I hear this all the time from architects. This is how it shows up for them. You know, that this thing that there is under management that we thought was fit for purpose, no longer fit for purpose. And of course, it's not even two different things. You could have code that you wrote that is starting to degrade, and it's in part degrading because the underpinning infrastructure is degrading, and you've had to make compromises. The supplier as a whole, now the previous slide might be just about a particular product, a well-known form of database or middleware that you need to get off of. Here is the whole question of the supplier as a whole, and we get plenty of inquiries around these. Certain suppliers that develop a business model of simply harvesting old software and running it into the ground and not maintaining it. This is a form of supplier debt. If you have too many suppliers that are in that model, well, your systems that you rely upon, the software products you rely upon, are no longer as reliable to you. You know, you're likely to get worse service at a dramatically increasing cost. And so if you have suppliers like this in your portfolio, it's a form of debt, and people have described it this way to me. Of course, security is a class of problems that would cross-cut everything I just talked about. It could be security decisions that your JavaScript programmers made that are no longer ideal, or it could be security aspects of products that you depend upon. You also might see a lacking in controls. You know, you aren't up to speed with the current exploits and risks and hazards, or you may have controls that are outdated and obsolete, and that you're spending a lot of money, providing these controls, but in reality, the real action is moved elsewhere, and so you're both wasting money here and not spending it where you need to over there. That's also a form of debt. We might see compliance debt because regulations are not under your control, and yet they do impact you. And privacy, health, we all know the usual suspects, and they're continuing to enhance these. And so if you're not paying attention, do you have the capability to track changes in the regulatory regime? Not having that capability might be construed as a form of debt. Process debt, under or over specified. Processes, as I alluded to with the controls question, but more broadly, we've always done it this way. We don't know how it adds value. It sure slows us down, but we just expect it. And no, we haven't automated it, and there's an opportunity there. And of course, a lot of this then results in the fact that you have people whose skills are obsolescing, and you have shortage of skills for the new platforms. You're relying heavily on a few talented individuals, and they are overburdened. And in the meantime, you have people whose skills have been rendered obsolete by the fact that you have sunset the technology that they were used to working on. Do you have the capability itself to upskill them? And that also would be a form of debt. Hardware is very well understood. We have capital. We sweat it out for 5 years, and then we decide, we can get a 6-year out of it. By the time you get to year 7, you're on eBay looking for surplus power supplies, because you can't, the vendor will no longer provide you replacement parts. And then, of course, you might decide to make large-scale changes in your operating environment, even in your actual architecture of your data center. And so, to the extent that you haven't moved over to these new types of fundamental computing architectures, then you might experience that as a form of debt that certainly is going to slow you down, because hey, we can't run this new thing without the latest and greatest hardware or infrastructure. For those of you, of course, who are still on-prem. This is a favorite of mine: inconsistent, poor quality, poorly governed data that can't support analytics. You run two reports that should be the same, and as indicated in the graphic on the left, you're seeing inconsistent results across reports. And this is all traceable to problems with the data. I just was doing a case study on Target Corporation. They tried to expand into Canada and had a pretty dramatic failure about 8 years ago. One of the major reasons they failed was because of data governance and data quality, and insufficient attention to data quality. Something that small, and it really, their whole supply chain just broke down and they had no goods on the shelves. Can't run a retailer like that. Now, this admittedly is more of a conjectural one, but I like Sriram. He's a good guy. He wrote the book Agile Organization Design, very thoughtful solo cat out there. And he proposed that if you believe in a data-driven decision-making, that you're running experiments, well, if you don't have the ability to baseline the experiment and do a meaningful comparison against it, then he proposed that this was a form of measurement debt. And I'd say that your inability to measure technical debt is itself kind of a form of debt, meta debt, if you will. Now, how do we handle technical debt? There's a lot to operationalizing it. You need objective criteria. You perhaps need subjective abilities to survey architects and subject matter experts. I do think that we need to centralize certain aspects of it, because there is a data management problem at scale that starts to revolve around the configuration management database or similar infrastructure. You might center some of it on your package manager. You might center some of it on your DevOps toolchain, your integrated software development platform. All of these platforms produce data that can be used to generate technical debt reporting. And I also believe that you should have some ability to survey subject matter experts, and you should track the results of those surveys as to their subjective opinion about the quality of the system in question. Doing this on a regular basis is something that enterprise architecture groups often do. I personally participated in a large bank. We called it the Critical Systems Review. And every quarter, we analyzed 3% of our critical systems and looked at things like technical debt. It was a very good practice, and it was also required by the regulatory authorities. So there. I do also often use this life cycle model. Now, we all have our mental models. I came up with this one about 12 years ago. It has stood the test of time. I've had many mental models that I've thrown at the wall like spaghetti, and they don't stick there. This one has been very, very sticky. It's a very useful way of understanding the life cycles. Debt can arise in any of these life cycles, but they are very useful life cycles to understand as decoupled from each other, because they are decoupled from each other. And part of the challenge we run into in large-scale digital organizations is lining them up so that our choices of technologies are reflected in our invested asset base on the floor, on the ground, and that these are both then supporting the platform services, which support in turn the application services, or the actual end user facing products, as people might prefer to call them. So I've written reports on this. I won't go into a lot of detail on it, but it's certainly something that I do enjoy talking about. And if anybody is interested, drop me a line. And finally, we did run some we are starting to ask people what their level of concern is about technical debt. We do see that a majority will say that they are somewhat or very concerned about technical debt. Only 20% are unconcerned. I do think that this is a topic that will continue to take up people's mental energy, especially if the economy starts to become a little more troublesome. Sometimes you then have to make harder decisions around technical debt and what your go forward platforms are going to be. I know that when it comes to the question of data, that this is certainly also keenly of interest to software improvement groups. So I am at this point, I'm going to hand over the presentation for my friend and colleague Jasper Geerts to pick up from here and tell us a bit about how SIG is providing services and engaging with this problem. Over to you, Jasper.
Thanks a lot, Charlie, and thanks a lot for your insights and bringing, let's say, the fresh and new definition to the market in this way, right? And we completely agree with that. And I'll talk a little bit about our views on how to manage technical debt in a systematic way, and I think they overlap quite well also with your model that stood the test of time. The Software Improvement Group is not as well known, I think, as Forrester, so let me just quickly introduce our company. We've been objectifying software quality since 2000. And if technical debt is deferred maintenance, then quality could be the opposite, right? If you have a very high quality software system in many different aspects, then our technical debt is also lower. So we are a spin-off of a university in Amsterdam, a couple of professors that did research to COBOL systems to come up with models that could predict risks and how to mitigate these risks. And fast forward 23 years later, we've created all kinds of different measurement models and technology in order to provide insight into software quality. So currently we've analyzed over 9,000 enterprise software systems, ranging over 300 different programming languages and 75 billion lines of code that we've scanned that we've seen before, and about 1,750 plus development teams that we supported. So we're not a system integrator. We're essentially, as we started as a advisory firm, and now we're growing into more of a platform organization, because all of this data and all of this information and the experience, we put that into our software assurance guiding platform that we call SIGRID, that provides all this insight for our customers. All right, so given that context and that experience that I personally also have in working with 100 plus different development teams, we let's come up with let's say a simple approach, a simple model on how to manage technical debt in a systematic way. And obviously, this is there are multiple steps involved, and some of these are also in parallel. But essentially, it comes down to this: in order to manage technical debt, that broader definition in a systematic way, we need to index where that is, right? So Charlie just discussed this as well. We need to make sure that we measure all the systems and assets that we have in our T landscape, ideally in an automated way, because then it can be redone oftentimes. The second step is to determine investment opportunities in the technical debt. There's a vast amount of technical debt in our software landscapes, and not all of the technical debt has a positive return on investment if we were to invest time and effort into it. So we have to come up with a way to determine what is an attractive cost benefit. Then we need to align this with strategy. So there's a very important step that technical debt is not just a technical problem for tech teams, it's a business problem, also for financial teams and for business people and the C-suite. And then, of course, we need to enable our developers in a way to improve the assets and to reduce the technical debt. We need to provide clear guidance. And in a short talk, I'll talk a little bit about all of these different steps and our views on that. So the first step is to index all the technical debt. So where is the technical debt? Where does it live? And again, Charlie discussed many different places where technical debt may live, and this is, this can be one of them, right? So that you've got this software landscape, and it's described in diagrams, which is a good way to describe your reality. But when you go into all of these assets and actually measure the interdependencies between them, oftentimes what we see is an implemented software architecture that is much more complex. And this is just one way to talk about technical debt, is the dependencies and the anti-patterns in our architecture. But this is what we as SIG try to do and try to bring to the market as well, is to be able to measure as much of this in an automated fashion. So then the question becomes, what should we measure? A lot is the answer, and you can measure a lot in an automated way, but you also need expert opinions and that kind of stuff. But let's start with product quality. So singling in on a single asset, for instance, an application, a web application. There's all kinds of things that you can measure about this, right? You can measure its maintainability according to the more traditional technical debt definition, means the complexity in which code is written and the redundancy in the code itself and the way that that is architected. But there are many other things that we can measure. Security, we've got a lot of open source scanners, we've got closed source scanners like checkmarks that you can run that gives you a lot of findings and information that is related to technical debt. Same goes for performance and reliability. How does this run in a production environment? Is there any failover? If you don't have that, that could mean that you have technical debt. So this is something that you should measure. But then we, of course, have metrics that can look over multiple systems and portfolios of systems. For instance, our architecture quality model helps with that. So what kind of technologies did we actually pick? How did we design our software landscape? How do we structure it, and how do we control data access to all of these different data stores that we have? And then there's social metrics, like what is the knowledge in our organization right now? So what we do here is, for instance, we look at the Git history and commit history of development teams to understand where are they working, how do they evolve the system. This helps you also determine what is the important debt to focus on. And there's, of course, lots of other metrics, process quality. Charlie just mentioned it as well, and things like hardware and infrastructure. But I want to focus on these elements that you can see here. So, and these are not, you can't single them out, right? These things are doing something together. So recently, I actually delivered a project for a large bank that wanted to acquire a company here in the United States. And we found that the target team actually had no input validation on fields that are actually exposed to users. And if you don't have that, then you can, as a malicious or an attacker, you can basically inject malicious code that could be executed, right? Stuff like drop database, or you can steal sensitive information by that. So that in and of itself is technical debt. That is something that needs to be resolved. For whatever reason, it wasn't handled well. It could be developers didn't know. It could be it wasn't a priority. Maybe something has changed, but it is technical debt. Well, if you look a little bit deeper, so why is this problem there? It turned out that these developers, they actually created their own front-end framework. Whereas we all know that there's a lot of great frameworks and libraries out there like React that you can use that can actually speed up this process where you don't have to deal with input validation yourself. And that is considered technical debt. That is design debt, right? So why did they design a system where they wanted to kind of create their own front-end framework where there's something readily available that also gets updated by the community once there's a new version of a browser? So that's kind of the technical debt that we talk about. So that's a lot of findings, right? If you have all kinds of tools and that help you out defining and getting these findings. So how do you interpret what this means? This is kind of where you need to overlay frameworks, international standards and benchmarks. So things like if you're in banking, you know that you need to adhere to the PCI DSS version 4, for instance. Well, you can have these security findings and overlay that and see, am I compliant? If I'm not, then you can interpret that you probably have a lot of technical debt there. But there's other frameworks, the 12-factor app, right? If we want to go and move our applications to the cloud, this is a way to determine how far we are in that journey and what we could consider technical debt. We use the ISO 25010 and the ISO 50055 that help define these different aspects and to create these measurement models. But there's of course also benchmarking involved. I think Charles, you mentioned it as well, is you have to compare it either to your own teams or to the industry to see what do we consider to be good enough. So what is the technical debt that we can have, and what is the technical debt that we can allow for? In our practice, though, what we see, and this is again a simplified version of what a software landscape looks like, is that there's of course a lot of technical debt. Right? Whichever definition you apply, there's going to be a lot of it in large enterprise landscapes. And if you single that out and compare that to the overall size of a landscape, it's actually quite significant. Right? But that doesn't mean that you have to solve all of that. And this is kind of where step 2 comes in. We have to determine investment opportunities. So what is the technical debt that we actually have to solve for? And as it turns out, the majority of technical debt you can leave alone, because there's obviously theoretically a host of improvement possibilities and things that you can do, but in reality, you don't really have to tackle all the debt, right? So there's 80% of the technical debt you can leave alone, just because you already know that this is a legacy system that is dormant, that we know that we're already replacing by a modern architecture, and that we're slowly building or breaking down. So it is about that 20%. So how do we get into that, and how can we determine if we actually need to focus on that 20%? An example of that is the investment of deferred maintenance in an application like this. So this is just a graphical representation of what an application could look like. This is an average size application from around 500,000 lines of code written in Java. Every block here represents a method or unit of code. The color represents essentially the complexity of it, and the height of the bar here represents the size of that unit. So it's totally fine to have some complex and harder to read code inside of your organization or inside of that application. But if you compare that to something else, then you can kind of see where the technical debt is. So obviously there's a lot of technical debt here on the right-hand side. And if we then calculate on how much that is, and again, SRG uses a benchmark methodology where we say for a Java application, the left-hand side, it's less complex, it's more maintainable, it's safer than what we see on the right-hand side, which is below the market average. And the nice thing, if you know this, and the teams know this, right? So the teams always know that there's a lot of technical debt that they need to deal with if they work on these type of systems. But you can quantify this. You can look at what is the volume here, and what should I do? What is the deferred maintenance? So how much should I invest, or could I theoretically invest in order to remove all of this technical debt? And you can see that it can exponentially be pretty big, right? The picture on the right, it says this application is around 30 person years or developer years in size, and it would take one person 18.7 years in order to resolve all of that. And it's rarely the case that you actually need to do this or should do this. For this example, for instance, we know that this is an application that runs very stable in its environment. In the past year, there were no production issues whatsoever, and it's nicely tucked away behind a firewall and nobody can actually see it. So that doesn't mean that the technical debt is not there. It's just that you don't have to deal with this on a day-to-day basis, right? So this is maybe not your priority. What you do know is if something crashes and you need to be in this code, it's probably going to take you a while to understand it, and you need to test it well. But in terms of resolving the technical debt, that doesn't necessarily have to be a priority. So who makes those priorities, and who are the people that can make those type of decisions best? So those investment decisions in our experience are typically delegated to development teams. But if you look at this mountain range, for instance, and we ask a developer, here's some limited time for you to refactor your code in order to resolve some of the tech debt. A developer could easily identify where they would put that time in, right? They know what are the bad parts of the application. But if you ask a team lead, for instance, they have a few ideas in mind. Maybe they are managing multiple teams and multiple applications where they say, well, actually, this is the highest peak. It's better to spend that limited time here on this peak here. But it's actually the CIO who should have a vantage point that is higher than everything else, and that understands this is what the software landscape looks like. And these are the important bits. These are the parts that we should allocate that limited time. So technology debt or technical debt is not necessarily only a technology problem. It's a business problem. So what you see here is a nice model created by Professor Visser to describe all the different forces that are pressuring on a software landscape or an IT landscape. It's customers, governments, and suppliers. So the customers, I always want cost reductions. They want you to innovate, otherwise maybe they need to go to your competitor. So you need to continuously optimize the behavior of your landscape. Regulatory requirements, they continuously change and they force you to adapt. And then you have, of course, co-evolution, suppliers that you rely on, that you're integrated with through APIs or whatnot. And then obviously there's commoditization. So there's always a library somewhere that you can swap out that highly complex code that you've written 10 or 20 years ago. So what the technology leadership needs to do is then, of course, look around, look ahead, and look inside. So look around in to see what is available as commodity, something that we can use, that we actually build, that we don't need anymore. We need to look ahead. So where do we want to be? What is our market going to look like in 12 months or even 5 years? And then we need to look inside. That's what we discuss. What kind of assets do we have and how much technical debt do we have? Which is then, of course, that anchor that Charlie talked about, because that anchor is going to weigh you down quite significantly if you want to win in the industry, right? And everybody, the customers, the enterprises nowadays, they want to be agile, they want to be scalable, they need to be compliant, they need to be cost effective, and everything needs to be available all the time, right? And this is why we believe this is not something that just developers or technical staff needs to solve. This is something that the organization needs to solve as a whole. And there's a very nice tool available. It's recently published by McKinsey, where they really say that the cooperation between business and technology leadership is essential in breaking down technical debt. So you have to have this common technical debt language that also the CFO, the CEO understand, that we can factor into what the cost of our entire IT services are actually costing. And by knowing this and by being able to calculate what those budgets should be, we can actually allocate resources in order to structurally break down the technical debt. So from the CFO, we could have, for instance, funding to have a specific product owner and an application modernization factory, so multiple teams that are working on modernizing the technical debt, right? At the same time, from the CIO office, we can say we have dedicated people that we now put in those teams that are focusing on the technical debt that we currently already have, right? So, and put that into practice a little bit, imagine this is a landscape where there's a core banking app, and applying these metrics and this methodology, and these are abbreviations, but this basically our architecture metrics, right? So the strength of the communication, the way that's integrated with our data warehouse, and the technology stack that we picked. But you can see that there's a few things that are considered to be like low scoring: evolution and knowledge. So if the core banking app, and this is kind of what we say, if that comes from a strategy point of view, we know that we need this app to be alive and kicking in 10 years. We need to focus on this because we rely on people that actually don't have specific knowledge anymore. Now, if you know that you need to modernize this, then you can basically come up with different scenarios. But given that it's structured in the right way, we can go, for instance, for replatforming this, which basically means that it's running on an on-prem in our own data center. We need to replatform it into a public cloud. This means that we need to break it down into services in order to utilize the cloud in the most efficient way. So that seems like the best scenario here. And what we can then do is determine what this is going to cost in the long term, right? So initially we have to do an investment to replatform this application, but the costs will be significantly reduced, right? So your return on investment is going to be lower in the end. Is going to be in about 3 years. All right, so if we have decided and aligned with the business and now know which type of technical debt we need to solve, then we need to actually execute this. And there's many different ways on how we can do this, but the best way that we've seen is to have trust, right? It's to give development teams autonomy and empowerment to do what is right. So they have an allocated budget and they can actually work on the technical debt in a structured way. What comes with autonomy and empowerment is, of course, accountability and transparency. The decisions that are made, they need to be accountable for that, and they need to give and provide insight and transparency into where they are going with this application. And that can look like this, right? So SIGRID is that platform that I just introduced that we're developing, where you can actually track these type of investments, where you're saying, well, certain parts are currently improving, and sometimes we can see deterioration, which then basically means we have to readjust. And then the cycle starts over again, right? So once we have this, we start indexing again and reprioritizing to see what is the next technical debt that we need to solve. All right, this kind of brings me to the end of that model. So what we've discussed today, and thanks a lot, Charlie, for pitching and presenting your thoughts on technical debt. So we understand the different types of technical debt that we have. We talked about some practices on how to rationalize where that lives in our IT landscape, and how to prioritize technical debt to align this with our business objectives. And of course, on how to execute and take control of technical debt, and in the end, increase the agility of our organization. So with that, maybe Nick, I can hand it over back to you, and then we can have a discussion or some questions.
Absolutely. Yes, thank you, Jasper. So thank you, Charlie and Jasper, for your presentations just now. For the audience, if you'd like to learn more about Software Improvement Group and how we help our clients take a systematic approach to technical debt, using Sigrid, the software assurance guiding platform, we can set up live demos, walk you through that, and also, if you'd like a copy of the deck today, please do not hesitate to get in touch. Right, we've actually had some questions come in. This one caught my attention. Could you share some strategies regarding how different teams can deal with technical debt once it's been identified? Jasper, maybe if you kick off and then bring Charlie in.
Yeah, sure. Well, there's obviously multiple answers to that question. If it's a modernization, so what I just showed is a way of arguing about a larger portfolio or landscape with multiple metrics. This basically means that you can identify technical debt in each different component. So different teams can deal with this by not entirely removing the entire technical debt or rebuilding a platform. You can do this in an iterative approach. So what we see is sometimes the pause button is hit, and we're waiting for this perfect new system to arrive in 3 years, and that is a project that can fail. So what works much better is to do this in an iterative way. But that's very complicated because there's multiple systems that you rely on in an environment. So if the decision is made to modernize an application, you need to do this with an iterative approach, make sure that you have the right metrics in place. On a shorter scale, right, is that technical debt is something that you basically create every single day, and that it's fine as long as you keep it under control, right? So that is something that you can do. That's called the Boy Scout method, for instance. Whenever we're working in a system and we need to change something because of maintenance, let's make sure that we improve it a little bit every time. So write a test, make sure that security is in order and that the code is a little bit more readable for the next person that needs to be there. Those are two kind of extreme ends to the spectrum. Charlie, you probably have some good ideas there as well.
Well, yeah, I think the biggest challenge for technical debt for me is people starting to measure and track it, but then not following up. I mean, if you start a program to track it, then you need to understand that unless you have the intention of redirecting investments, changing some of your investment behavior based on that information, don't do it. I mean, you know, and I love the fact that you talk about how the investment should be ring fenced. You know, that's essential. You've got to make it clear to people. You've got to have the high level financial support that we will pay down technical debt. It's important to us. We understand that there are consequences if we don't, and therefore your portfolio of work should include, you know, some regular and transparent paying down of this. Now, I totally agree that the product teams at the end of the day have autonomy. We do need some consistent identification and reporting mechanisms. And that's where some of the infrastructure comes in place, including, you know, methods and tools such as you suggest here. We do need to compile this data. But once you compile it, you know, show me the money, show me the investment that happened, you know, as a result of people seeing this information and then taking decisions to fix it and invest in it. That's the key thing.
Yeah, and it also starts with the definition of done, right? And this is also typically delegated to development teams, but you have a lot of non-functionals that you can add as a requirement to teams. So it's just something that you can do as an enterprise, where you can say, this is what we're aiming for as an organization, and we need to make sure that everybody just adheres to this. And then to your point, Charlie, you have to measure it. And there's of course a level of control, and that comes with that autonomy, right? You have to have that accountability and the transparency that comes from the product teams towards those who, in the end,
some of it, I think it's critical to work this into an OKR strategy. For example, if you're working with OKRs, then one of your OKRs should be a tech debt thing, or it could even be more of a steady state health KPI. There's still debate about OKRs versus KPIs. OKRs being more programmatic. So I think that's another aspect of it is get it into your performance measurement. I do like, just to bring a little bit of a different thing, Mick Kirsten, who wrote the book From Project to Product, has something called the flow framework, where he says all work should just be understood as features, defects, risks, and debts. And I love this because I also think and I think you were alluding to this, it shows the importance of a common backlog. And this is something I've been preaching, for 15 years as IT analyst and architect. We need unified work management. And then a debt is just, it's a tag we put on some piece of work. So, a way to think about it.
Brilliant. Thank you. And then I think we just have time maybe for one more. I think you slightly alluded to it already in that previous question, but how long would it take, do you typically see it take to do an assessment of technical debt? And how often should you go through that measurement process? Because if you presumably you do it the once, it's just a snapshot in time, then you want to obviously see the progress of the effort that you've invested. Maybe Charlie, I could deflect that onto you first.
I very strongly believe it should be baked into your overall control plane. It should not be a batch process. Doing an initial baseline and setting up the system to track it long going probably can be done in 6 months with the right investment. Much faster than that, and I think it's a pretty complicated topic. And of course, you would iterate on it. You would develop an initial measurement, to call it technical debt telemetry. Pulling out maybe just starting with your code review system if you have one, starting with your CMDB and software asset management system if you want to start there on the more product side. But it should be a regular dashboard, and operationally you should be checking for technical debt as best you can, throughout your regular release cycle. I think that there are ways you could work it into integrated software development platforms. A lot of them make calls out to code scanning. That's a frequent use case for code scanners, is that they're invoked, on at least major releases in the automated CDRA pipeline. Continuous delivery release automation. So I think it never ends. Benchmarking, baselining will take you some effort though, for sure.
Yeah, I completely agree. And there's a lot that you can actually automatically measure and keep on a dashboard like this. So this is of course what Sigrid is going to do and is currently doing, is all the different scanners that we can make. Some of them are open source, some of them are off the shelf. Of course, you got open source scanners out there. All of that is something that you continuously need to do. But then obviously there are also things that you can't measure in an automated fashion. So once you've identified where a lot of technical debt is by using these type of automated tools, you could do a assessment with experts where they say, well, what does the design look like? There's tools out there that can talk a little bit about that, but there are metrics that are important to discuss technical debt. And Charlie, you mentioned a lot of them, and some of them can be measured automatically, but not all of them. So this is where you kind of need to do expert review, which takes longer, right? Because a lot of these systems are just very, very big and very complex. It can take a couple of weeks, sometimes months, to really, really define well where your technical debt is. But it's necessary. Otherwise, you will not know how much you have and how to tackle it in the most efficient way.
Yep, absolutely. Yeah, and for those of you with formalized architecture programs, a regular critical systems review, I think, is a very, very good practice. It is, mandated by regulations, at least in some industries, that you're regularly reviewing, and that should include your expert assessment. But then you track the results, and the experts can give you a numeric score. Make it a net promoter score. It's like, on a scale of 1 to 10, would you recommend this application to your best friend?
Yeah, and that's actually a good point. And I've talked with so many teams, and you also, Charlie, is I rarely see people that intentionally create technical debt. That doesn't exist, right? It's always something else that caused
Oh.
it. Why there's complexity, why a certain decision is made. It was the good decision at the time, but it's about like accepting that, and
Yeah.
it rarely has to do with people that don't want to build beautiful software, because that's always the case.
Absolutely.
Brilliant. Well, thank you, Charlie. Thank you, Jasper. I think that's all we have time for. For anyone who asks questions, we will take them offline and get back to you. And other than that, have a great day.
Thanks a lot.
Thank you.